and welcome. I've seen a lot of videos online recently with people reacting to um, celebrities or influencers, or what you call it, using different types of Linux distros, and hopefully I will create a good guided setup procedure for installing Arch Linux on a virtual machine. This is the same setup that I'm using on my currently recording system, but installing from a VM is easier with capturing and stuff like that, since I don't have a screen capture card. Main reason for wanting to do this is to showcase how you can set up a fairly secure operating system using Arch Linux install without using the Arch Linux installer, but directly. So let's dive in, and I'll start by showing the Ventoy boot screen. As you can see, I'm using Ventoy because it's simpler than burning disk images directly to, or than burning the disk images, because you can then use the Ventoy disk formatter to format the disk once, and you can actually add different ISOs to the drive directly, instead of having to manually handle burning once, and you can have multiple ISOs on the same USB stick as well. Because of restrictions, when you are using an EFI or modern system, will boot using the grub2 mode. I'll start the Arch installer. First things first, we'll check that we are actually connected to the internet. I'll ping archlinux.org 3 times. And it works. If I were on a laptop and had to use wireless, I would use IWCTL, first list devices. Then I would probably have an adapter called WLAN 0, for instance, here. I would call if it were off, I would have set the property powered on. Then I would probably have used something like IWA CTL station show to get the stations. I would get the network next. And then I would probably connect to the SSID. And the command looks something like this. actually, if the brackets wouldn't be there, of course. And you would get prompted for a password, and then I could ping Arch Linux. Next, I will use time datectl to check date and time. As you can see, I'm on UTC time for now. I would probably I will adjust this later when I get to the operating system, but for now it's good enough that I'm on UTC time. Next, we'll start by formatting the NVMe drive. Before we begin, I would probably use something like lsblk to get block devices. As you can see in my system, I have SDA, which is the USB device with Ventoy, and I have SDA, NVMe 0 and 1, which is the disk where I will be installing Arch Linux. On a normal NVMe disk, before you start to install a new operating system, I would recommend using the NVMe command to format. The SES equals 2 flag tells NVMe command to do a secure erase. Reset tells it to reset sectors and garbage collected stuff, and actually reset as if it were new. I will issue the force to avoid 10-second delay, and I will say the disk I want to format. It's fairly quick on a 32 gigabyte disk, but on a larger disk it will take a bit longer. It will still be quicker than formatting using DD or stuff like that. Next, we will partition the disk. I will create a GUID partition header. I will create the EFI partition. 1 gigabyte should suffice. I can type L and show codes here. I know for a fact that I want an EFI partition for this, and that's the code for an EFI partition is EF00. As you can see, it's changed type to EFI system partition. Next, we'll create the Linux encrypted partition. We'll use the remaining. Default code is a Linux system. It's fairly okay to use, but I tend to use 8309, which is actually telling the system, which is code for LUX formatted Linux. Next, we'll write. I'll create the FAT partition first. EFI as I'm misremembering, I think. Yeah, I'm misremembering. N for KSFAT. There. Next, we'll create the LUX for. Okay, first things first. If we were to install on a real system and we wanted to hide data boundaries, this next command will help you do that, or the command I'm typing right now. I can run I will showcase running this now, but in reality you don't need to do this if you don't want to hide data boundaries. It's a bit of a paranoid setup maybe, but it's good to do if you have privacy concerns, I think. This will write directly to the disk instead of caching on the RAM, so it's fairly quick on a 32 gigabyte disk. If you have a terabyte, 1 terabyte or larger disk, it might be slow. As I said, it will help you prevent showing data boundaries, so that's a thing to think about if that's something you want. Otherwise, it's not required. I will pause the recording now, since I don't have anything more to say about this until the dd command is completed, and I will resume after that. Okay, now the disk is completely scrambled, so we won't be showing any data boundaries. Now we can format the disk using crypt setup. Because we are using grub as a bootloader, or rather, since we're using grub as a bootloader, because we are want to have a fully encrypted system, we have to specify a couple of extra flags here. The first one says which algorithm we're going to use to hash our password into a key. The next states which hash algorithm we want to use. PBKDF2 is supported by grub. Argon2 ID, which is the other option, is not supported directly. I think you may be able to make it work with a lot of tweaking, but I'm not going to showcase that in this video at least. Okay. I mistyped here. Next we'll type yes with caps lock on because it's required. Password, I used the Norwegian word for secure in this spanner, but on a real system I would of course use a more secure password than that. Next we'll mount the system. Call the rootfs for rootfs, or maybe just root to make it simpler. I'll do rootfs. That's what I normally use. 20 passphrase. Now I can create my btrfs file system on this mounted drive. I'll label it rootfs. The rootfs can, as I stated, be named whatever you want. I just prefer to use that. Next, we'll mount rootfs, and we'll actually create the different subvolumes in btrf or btrfs. This structure I'm choosing to use is not the same as used by Debian, but a bit similar. The thing is I'm using a subdirectory, which will be the root. Home, a separate subvolume for home, and root's home is at root. At boot is the boot directory. At log and at pkg subvolumes are there, so that when I create snapshots, I can avoid snapshotting those, since they will be fluctuating and growing a bit. And the snapshots subvolume will be the subvolume for keeping snapshots. I will not be showcasing how to install or configure any snapshot utils for now, but I do tend to use cron scripts for snapshotting myself. Next, we'll unmount and remount with the now subvolume, with the correct subvolumes. The mkdir switch here, command line switch here, is actually so we can mount without having to create the structures in beforehand on the root file system. I'll have to pass some options. I'll use no time, compression. I use set std compression. I think there are different options as well, but I find that's the easiest to use without any changes. Next, we'll mount the home. And last, we'll mount the snapshot subvolume. There. Or last of the btrfs file systems. We'll also have to mount the EFI partition. I'm using capital letters EFI just because I find that's easier to remember that that's an EFI partition, but I think the default should be lowercase. Next, we'll have to select package mirrors. For this, we will use reflector. I will now be running this command without selecting a specific protocol first to show how the output would be with and without the protocol selection. And as you can see, I've now selected both HTTPS, rsync and HTTP mirrors. I prefer to use only HTTPS. I can also say, for instance, if I want HTTPS and rsync. As you can see, I now got only HTTPS and rsync mirrors, and if I remove rsync as well, I will get only the HTTPS mirrors available. I'll save that to the mirror list. And now we can start installing the system. This is an Intel computer, so I'll install Intel ucode. I'll also install NeoVim and bash completion. Now, and I'll actually include sudo as well, so I can get to jump start on configuring. This will probably take a couple of minutes, so I'll join you back when the install is completed. And now the installer is completed. So next we'll create the fstab file to get the correct mounts. So I use gen fstab for that. -u to use UIDs. We'll use mount as the root, and we'll pipe it to the end of fstab that's already there. Now we can ch into installed system. First thing I'll do is install a bit more packages. I tend to use update pacman, although this isn't necessary because it's normally fairly up to date after installation. Now I'll install the remaining tools I need. Because I installed bash completion in a previous command when installing with packstrap, I now have access to tab completion. So I'll be using that. I installed sudo already, so I think I did install NeoVim as well, so I don't need that. I'll install fast fetch, and that's it for now. No, sorry. Yeah, that's it for now. I could, of course, add more tools as well, because we will be needing grub and grub btrfs and a couple of other tools, but just so I'll issue one more installer command next. The grub btrfs command will actually enable you to boot from btrfs snapshots when grub is recreated. I'll install Network Manager. I'll need, because we're using an EFI system, we have to use the EFI boot manager. I'll install UFW and USB utils and wget. If this was a laptop, I would also install wireless tools. So like that. I can actually leave that in. These installations are fairly quick, so the thing takes the most time is actually to regenerate the initramfs. The possibly missing firmware module for different things is fairly normal, and you can normally ignore most of those. So I will be ignoring them actually. Next we will excuse me a second. Next we will be setting up our environment. First I will be setting the local time. so Europe Oslo is of course our capital. And if you see now, I'm at Central European Standard Time. Next, I'll create a hostname. And we'll create a separate boot key for our operating system. This is to avoid having to type the password twice. If you don't do this, you'll have to enter the root FS password twice during the boot setup. I could of course use any name of the file I wanted, and I can actually install it to where I want as well, but this is a fairly default way of doing it. I forgot the counts, so I'll have to adjust a bit so we don't get that large file. Next, we'll add this key file to our crypt setup. And we'll have to type our original password. To add it to the Lux keychain, or keys allowed to decrypt the disk, that is. Next, if I can use you can see we have key slots 0 and 1 now in use. Next, we'll modify mk-init-cpio configuration to include our current key into the initram file system. For this, we will fix such so we blank filler line. There's probably better ways to do this in NVim, but to ensure we type the correct file name, I'll actually use NVim's ability to or Vim's ability to insert at a separate line. I'll add the encrypt hook to MK in CPO, write out the file and close. Now I can run MK init CPIO with a P option. It will now use and embed our installed crypt key. Next we'll have to use the same for grub. We'll enable the crypt disk option here. That's just removing the comment on that line. Then we will navigate back up here. I'll navigate to the end of the file. I insert and I'll add a crypt device. I'll also add the crypt key. Next, we'll actually add the UID of the disk there, and we'll install or add the key location here. I'll use Shift J to join the lines and an X to remove the space. Write out and quit. Now we can install grub. I'll use x86 EFI as target. The EFI directory is in EFI, and we'll use bootloader ID grub. Next, it says no error reported, so it seemingly went okay. Next, we'll use mkconfig output to boot grub.cfg. Now we actually have everything we need in order to have the system bootable. We're still lacking a couple of configurations before we can boot into the system and be able to log in. I'll set a root password first. I'll now create a user. Default with access to group wheel, and use my username, which is proihave. I'll set a password for my user as well, so I will be able to log into that user. Now we'll add a link to V and Vim in to nvim or neovim from the vi and nvim command. We'll run vsudo and I'll search for wheel, and I'll remove 2 characters on the next line. That's it. Now we should be able to reboot the computer. So I will be doing that. Or, sorry. I'll also enable the network manager to be connected to the internet when I boot it. Now we will be prompted with the boot key. I'll add the key I created initially. And we'll see that we're booting into our Arch environment. Next, I'll log into my personal user. And I'll ping Arch Linux.org. We can use a couple more just to see that we're online. Now I can install the remaining packages to be able to boot into a graphical environment. I'll use GNOME Desktop Manager for a login screen. I'll use Alacrity as my terminal. Also tools for sound tools, HyperIdle to handle wake up and sleep, HyperLand desktop environment, HyperLock, also install Swaylock, Dolphin, File Explorer, Bluetooth utils, brightness control for handling screen brightness on laptops. It's not necessary on desktop computers. I'll install both Firefox and Chromium, as I'm normally using different profiles there. For Waybar, I will install nerd fonts. And font awesome. I'll install wireless tools. Woofy. Network. I didn't install Waybar yet. Loop. Clipboard. I need a VLC. VLC. VLC plugins all package. And totem. I think that's it. Now I'll add my sudo password. And I'll actually use pipewire jack. I'll use ffmpeg. I'll use the GNU free fonts. Provide font provider. As you can see, there is a lot of packages that is going to be installed here, but it'll be fairly quick as regardless, because most are fairly small. The next thing I will be doing after this install is to enable GDM and reboot the computer. You can start the GDM directly, but I would advise against it because you will be logged into the console as well. Okay, now it's installed. As I said, I'll use I'll enable GDM. And then I'll reboot. Now we have actually installed our graphical user interface, and you'll see that when I log in now, I will be presented with a login screen. The last thing I will be doing is to log into the GNOME desktop actually. If I type my password correctly, that is. I'll open Alacrity. And I'll actually go to create a new file, directory, sorry, called git. Clone my own .files directory. Next, I'll go to and create the config directory if it didn't exist already. I'll move to config directory and I'll link up Hyperland. I'll create an Alacrity directory. I'll link in alacrity.toml and I'll link in my neovim config. You see now I have Hyper and neovim symlinks to that directory. I'll now do the same with the bashrc file. You can see my bashrc file is now linked to my bashrc in my .files. I'll source my bashrc and you can see my terminal now changed to a default different prompt, which is the prompt I prefer. Now I will close out the terminal and log out. And I will log into Hyperland. There's a cogwheel down here where I can change where I want to log into. Now I can change Hyperland and my configuration and setup will be correct. Because this is a VM, my screen resolution is terrible, but if I now open my terminal, you can actually see that I'm in Alacrity with a white background. If you followed along till now, thanks for watching and have a great day.